Hello all, good morning. This is Dr. S. Subbalakshmi, Assistant Professor in the Department of Mathematics, SNS College of Technology. This is a lecture video series on the course Matrices and Calculus, and we are on to the topic Leslie model. So here we have, in the previous video, we have seen this problem regarding the Leslie matrix, wherein the animal population is 6 years and it is divided into two age groups, two age classes in three age classes with 2 years each. So this is our Leslie matrix here. This is our Leslie matrix. With this Leslie matrix, the first question have been calculated. What is the total number of females in each class after 2, 4 and 6 years? If the each class initial contains 500 females. This problem have been computed in the previous video. Now we will move on to the second question. What is our second question? For what initial distribution will it take the number of females in each class change by the same proportion? Same proportion. That is, what is the rate of change? So here we have to deal with the eigenvalues and eigenvectors for finding the rate of change and the change happening in the eigenvectors, which is x1, x2 and x3. So we are going to find the initial distribution of the animal population, wherein the number of females will be there in each of the classes will have to change by the same proportion. This is proportion. And you are given that the initial population is 500 in each of the classes. Now we will move on to the actual problem, the second question. So firstly, we will be writing the distribution vector. What is the distribution vector? It is nothing but Lx minus Lx is equal to lambda x, where lambda is the rate of change here. So this is what we are going to find. Rate of change is our thing we are going to find. Therefore, on bringing this lambda x to the other side, we will have L minus lambda into x is equal to 0, which is on the matrix form L minus lambda I into x is equal to 0. So this is our matrix form here. So to find this, we are in need of the characteristic equation as a first step. So what is the characteristic equation? The characteristic equation of a 3 cross 3 matrix is given by lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to 0. This has been learnt as a formula in the previous video. And what is s1? It is the sum of the diagonals. It is 0 plus 0 plus 0, which is 0 again. And what is s2? Sum of the minus of the diagonals. So it is minus 1.38 again. We all know to calculate how to calculate S1, S2 and S3. S3 is nothing but the determinant of the given matrix A, which is here lambda, which is here L's determinant. So its value is 0.072. So this is what we have calculated as S1, S2, S3. So on substituting the values in the above formula, we have got as lambda cube is equal to lambda cube minus 0 lambda square minus 1.38 lambda minus 0.072 as a characteristic equation. Since it is a 0 here, we will just skip off this term alone in this thing. So now we are going to find the eigenvalues. How we will find the eigenvalues? We have to factorize the characteristic equation. And we have to use trial and error method. For calculating the first factor or the first root. When lambda is equal to 0, its characteristic equation is not equal to 0. When lambda is equal to 1, it is not 0. And lambda is equal to 2 is not 0. So on finding the value, we will have that lambda is equal to 1.2 is the root of the characteristic equation. Therefore, using synthetic division method, we have computed the value of lambda here using the formula lambda is equal to minus b plus or minus root of b square minus 4ac divided by 2a. This formula have been implemented here and found the values as minus 1.48 and minus 0.052. So what are the values of lambda here? 1.2 minus 1.48 and 0.052 for a cubic equation here. So since the lambda is a growth rate, so we cannot take it to be negative. Therefore, we will keep only the positive value. So the only eigenvalue is 1.2. What is our eigenvector? L minus lambda I into x is equal to 0. On computing this and finding the star equation, we will have the star equation as this thing. Minus 1.2 x1 plus 2.3 x2 plus 0.4 x3. This is our star equation. Using this, we are just going to substitute when lambda is equal to 1.2. By using cross multiplication method, we will be finding the eigenvector. There is only one eigenvector here. So now we have found the initial distribution. Now we have found the initial distribution here, which is x1 is equal to 1, 0.5 and 0.125. And we are asked to find the initial distribution in which all the values in the stages should be same. So we have mentioned all the x's to be x1, x2 and x3 to be x. Therefore, it has been written as x plus 0.5x as x2 and 0.125 as x3 here. So all these values have been replaced here. And what is the initial population given? It is 500 in each of the cases. On adding it up, we have this value of x to be 923.07. So finally, what is in age class 1 for the initial distribution to be in same proportion? It is 923. In age class 2, it is 0.5 into x. So on multiplying it, you will have 461 approximately. And finally, it is 0.125 into x and it is 115. So the rate of change is 923 and the initial distribution for the same number of female and initial population is given by for age class 1 it is 923, in age class 2 it is 461 and in age class 3 we have 155. So this is how we complete a problem on Leslie matrix and this is an application and implementation of eigenvalues and eigenvectors. Thank you.